Hello everybody, now we are going to solve a problem from Fundamentals of Electric Circuits by Alexander and Sadiku's 5th edition. This is practice problem number 9.9 and we are asked to determine V of t and I of t referring this particular diagram. Okay, this picture is to be referred. So what are all given here? This Vs, that is source voltage, is given as 20 sine of 10t plus 30 degree in volts, and here we have two components. This is resistor and this is inductor. Resistance is of 4 ohms value and this inductor is of 0.2 henries, and this current I is marked here. Okay, the current will be flowing through this and we are asked to find out this I and this voltage across this inductor also. And so if you refer this Vs, this is given in the time domain. Vs of t, we can write it like that. That is equal to 20 sine of 10t plus 30 degree in volts. So it is in the time domain. But we want to proceed with the phasor domain. Okay, so this Vs of t can be written in the time domain as 20 sine of 10t plus 30 degree volts. But if you want to go for phasor domain, we have to convert this sine into cosine. So sine x can be written as cos of x minus 90 degrees. So you here do the conversion here. Okay, 20 cos of 10t plus 30 degree minus 90 degree. So that becomes 20 cos of 10t minus 60 degree in volts. Okay, and now this time domain representation can be converted into phasor domain as Vs is equal to, here you will be writing it in small letter, but here you can write it in caps V. Okay, so capital Vs is equal to this magnitude 20 should be written here, 20 with the angle this should be taken minus 60 degree in volts. So this is the phasor domain representation. Now after converting this Vs in phasor domain, we go for finding the psi. Okay, so for that case, once again we refer this diagram. We can apply this KVL, Kirchhoff's voltage law. So it starts from here. So this capital Vs, for this we can apply Kirchhoff's voltage law, like this is minus. Okay, you start moving like this. So in that case, we encounter with the minus sign first here. So it is minus Vs plus 4 into this becomes capital I in phasor domain. Okay, so 4I plus this impedance of this inductance, that becomes j omega L into the current which is flowing through that is I. Okay, so we are writing this as minus Vs plus 4I, and then here it is plus j omega L into I, that is equal to 0 in a closed loop, right? Then instead of this Vs, we can substitute the phasor domain value as, okay, minus 20 angle minus 60 degree plus 4I plus, what is this omega? Omega value is given in the problem itself as 10, isn't it? So here you can refer, in this it is given as 10t, 20 sine of 10t, this represents your omega, so omega equal to 10. So here plus 4I plus 2, how do you get this 2? This omega is 10 multiplied by zero point 0.2, which is the value of this inductor, and then I is there. Okay, so you multiply these two things, then you will be getting this 2. So 2ji, that is equal to 0. You can keep these two terms on the left hand side, and this term can be brought to the right hand side, so that you will be getting the plus 20 angle minus 60 degree. Okay, now you can take this I outside, so that you will be getting this as 4 plus 2j, that is equal to 20 angle minus 60. Now you can have this I as 20 angle minus 60 degree, that is written here, and this can be brought to the right hand side. It is at the denominator as 4 plus j2. Okay, so here you have this thing, but we have to perform this division, right? Whenever you do the division, we prefer to have the values in polar form only. So this is in the polar form, but this is in the rectangular form only. So we have to convert this rectangular form to polar form, because we are going to do this division, right? So how do you do it? Using the calculator, there you have to press the shift key. After that you press the plus sign, or above which you are written this pole, that means that is representing polar. Okay, so we want to go for the polar form, so you can press this polar key, then you'll be getting this in the display, polar of within bracket you will be getting this rectangles. In the rectangles you enter this 4 and this 2. Okay, this is your real part and this is your imaginary part. So you have to write this real part as well as the imaginary part here, and then you press the enter. That then you will be getting this as your answer. What it is 4.47 with the angle 26.565. So you substitute here in the denominator. Then you can perform this division. So to perform division in the phasor domain, what you are going to do is just simply divide this 20 by 4.47, so that you will be getting this answer 4.474. Then you consider this angles. So whenever you get this angles you have to subtract it, okay, because you have the division. So it is minus 60 minus 26.565 degrees. Then you get the I, capital I, in the phasor domain as 4.474 angle minus 86.565 amperes. Here we got the answer in the phasor domain. Now it should be converted into time domain. Why? What is the necessary for that? In our problem, these I and V, that is the voltage source, is given in time domain only. And we are asked to find out this V of t as well as this I of t. That means time domain representation only. So that we are going for the conversion from this phasor domain to the time domain. So there this capital I can be written as small I of t, that is equal to this magnitude, that is 4.474 into cos of 10t. This represents your omega t. Okay, 10t minus this angle 86.565 degrees amperes. But in the problem only we have this sinusoidal representation, so this cosine must be converted into sine. So for that we are going to use this formula, that is cos x is equal to sine of x plus 90 degree. So this cos is now converted into sine. So you can write it as 4.474 sine of 10t minus 86.565 degrees. That means this whole thing represent your x here. Okay. So that x plus this 90 degree will be there. So that we get the answer as I of t is equal to 4.474 sine of 10t plus 3.435 degrees, this much ampere. So we got the first answer here. Now we are moving on to the second one, that is to find out this V of t. So we need to find out this voltage across the inductor here. Okay, so V of t is how much, that is what we need to find out. So in the phasor domain we can write this V cap as capital V, that is equal to the voltage across this inductor, isn't it? So that is current I multiplied by that Z, that impedance. So that impedance can be written as j omega L. That is the impedance of this inductor. So this I already we know the value in phasor domain, that is 4.474 angle minus 86.565 degrees. But you refer this previous one, here we got the answer as 3.435 degrees, but we should not refer this. We have to refer this only. Why? Because this is only the standard form, that is cosine is the standard form. So this whenever you want to convert to phasor domain, then we have to refer this thing only, cosine, not the sine format. Okay, so we referred this one multiplied by j into this omega, we know already that it is 10 multiplied by this L value, that is 0.2. Then here you see it is 4.474 with the angle minus 86.565 degrees, then multiplied by this j. Instead of j you can write it as 1 angle 90 degree, then multiplied by this becomes 2, isn't it? So then we are going to multiply these magnitudes together. So it is 4.474 multiplied by 1, then multiplied by 2, so that we are getting this as 8.94, right? And these angles must be added together. So minus 86.565 degrees plus this 90 degree will give you 3. That will give you the answer as 3.435 degrees in volts. Okay, so we got the answer for this V in phasor domain. Now we need to convert this phasor domain into time domain. So in time domain it can be written as V of t. V of t is equal to 8.948 into cosine. Okay, cos of 10t. This is your omega t plus this angle 3.435 degrees. Then you can write it as V of t is equal to 8.948 into sine of. That is, we need to use this formula. That is, we want the final answer in the form of this sine only. So that we are going to use this formula cos x is equal to sine of x plus 90 degree. So this cosine will be now converted into sine. So it becomes sine of this x value, that is 10t plus 3.435 plus this 90 degree by applying this formula. So it is V of t is equal to 8.948 sine of 10t plus 93.435 degrees in volts. So this is our answer for V of t. So we got both the answers. Okay, thank you. Hope you have understood.